This is Views and News with Clarence Ford.
Only on Cape Talk.
And at 9:35, welcome back to Views and News. Welcome, Chris, lecturer, of course, at the University of Cambridge, and this very important appointment that we have on a Friday.
Good morning, Clarence. It's an interesting week. You know, some weeks you see some science stories come through, and they really resonate. And this one is no exception. I phoned up Yi-Hing Chow yesterday, who's at the Karolinska in Sweden, because I saw he just published this paper. And he said this is probably the first paper in the world inspired by a can of fizzy drink. And what he was getting at is he's just published this work with one of his students on the effects of sweeteners, artificial sweeteners, and what they might be doing to blood vessels. And as somebody who occasionally partakes in the odd can of fizzy drink, not hugely, but some people drink lots of this stuff, and occasionally when I do drink it, I go for the ones which are low or zero sugar, on the understanding that, well, I don't want to eat the equivalent of half a bag of sugar because it's not good for my teeth, but it's also not good for my waistline. Well, his research feeding relevant quantities of this to in sort of human levels of consumption to mice, that he shows these animals get damage to their blood vessels over a period of time. You get more atherosclerosis, narrowing of the blood vessels, so it's more numerous in terms of where in the blood vessels are affected, and the extent of the damage is greater in animals fed on aspartame, which is the sweetener, compared to animals that are not eating aspartame. And their argument is, when you eat the aspartame, because it tastes sweet, it nevertheless tells the body, I've had a sweet meal, produce loads of insulin. And they were able to show that when these animals experience the sweetener, they have a big surge in the sugar-controlling chemical insulin. This binds onto blood vessels, and it, because it's there in such a high amount, triggers an inflammatory state when it binds onto a target on the blood vessels, that it puts the blood vessel walls into a state of inflammation, and it's that state of inflammation that increases the risk of damage to the wall of the arteries and therefore narrowing of the arteries. Obviously, he acknowledges this is an animal study, but he said the guy in his lab group who used to drink loads of fizzy pop that was artificially sweetened has now given up, and he said he doesn't touch this stuff with a barge pole either. So an interesting sort of announcement there, and one I think will probably alter my behaviour as well. Obviously, it needs confirming, it needs more follow-up, needs looking at this in humans, but nevertheless, quite a worry, isn't it?
So you are extrapolating from that, and so should we then?
I think it's not an unreasonable thing, because the mice they work on develop the mouse equivalent of what happens in human blood vessels. The mice are manipulated so that it happens more rapidly, because obviously in a human it takes 50, 60 years in many people's on average case to develop arterial disease. These mice only live for a couple of years, so you have to make it happen more quickly. But even so, it's acknowledged to be a good model for what happens in the human system. So if this is making these mice much worse, it could well be having an acceleratory or catalytic effect on the same disease, which is the number 2 cause of loss of life around the world. Heart disease kills about a third to a half of us. Cancer kills the other half of us, give or take. So therefore, it's going to affect a significant number of people. And he tells me that something like 2/3 of young people tend to drink artificially sweetened drinks. And these sweeteners are in everything. Because manufacturers want to sell you stuff and say it's low calorie, or this won't make you fat, or our biscuits are healthier for you because they don't have all this sugar in, so eat them. Actually, they've substituted a lot of sweetener for sugar, and the sweetener could well be accelerating heart disease.
Sure. That's not a nudge, wink, wink. That's a slam dunk. But let's go to Janine. Janine's on the line. I promised I would prioritize your call, Janine. Welcome.
Hello. I'd like to know from the Naked Scientist what effect there may be on the brain of a fetus if the mother has severe hypoglycemia during the pregnancy. I've read that the corpus callosum, the bridge between the right and the left brain, can be smaller if it's deprived of sucrose. And this in turn can cause personality disorders.
Hi, Janine. Well, the answer is that for a healthy baby, it has to have a healthy mum and a pregnancy of the right duration. And any departure from that, whether it's caused by infection, whether it's caused by a problem with mum's underlying health, or whether it's caused by a metabolic problem or malnutrition, there can be lifelong consequences. Now, it's obviously hard to study this in a human because we can't ethically do those kinds of experiments where we change or clamp or alter the sugar levels in mums and then see what this does to offspring. It would be completely unethical. So we're therefore reliant to a certain extent on natural experiments where this happens in patients and or in members of the general public, and then you follow up to see the consequences. I'm unfamiliar with people or the studies that perhaps you've been reading about the development of the brain, but what I can say is that sugar, glucose, is critical for the energy supply to many of our tissues, and it's the first resort of our metabolism. It's the first go-to source of energy. And to grow a baby in 40 weeks, which is what the human body does, to put all those cells, you're talking about tens of trillions of cells into the right places in the right proportions at the right time, is hugely metabolically demanding. So if you starve that baby because mum is starving, because when the human body has low levels of sugar, that's effectively a starvation state. It's telling the body you must be starving. It will rob away growth providing energy from those tissues, and almost certainly there will be consequences. We know that when mum starves in pregnancy, there are definitely consequences. One study that looked at this was one that was published in the journal PNAS. It was about 15 years ago, and they were looking at the Dutch hunger winter. And the author of the paper was a guy called Bas Heijmans. And what he found was that people alive today who were in utero at the time of the Nazi occupation of the Netherlands, where people starved, those individuals have developed a tendency through the rest of their life towards a number of metabolic problems like high blood pressure, stroke, heart disease, and diabetes. They found that the genes that control sugar and insulin signaling in the body in those individuals had additional markers called epigenetic marks added to them that altered their potency or effectiveness. So this appears to be a response to in utero challenge, as it were. So I don't think it's entirely implausible that there will be long-term consequences of this and almost certainly short-term developmental consequences. Babies robbed of calories during development can develop what is called intrauterine growth retardation. So I wouldn't be at all surprised, given how complicated the brain is, how fast the brain is growing, that at early periods in pregnancy when all the major organs are forming, if you have low levels of sugar, you may well have consequences in the baby. But I would need to go and check for the proper published evidence for that. And perhaps I could come back next week and tell you what I find, if that's okay.
Thank you, Janine, for your call on the topic of published evidence. Morning, Clarence. I'd like to hear Dr. Smith's take on the rise of AI in medical journal writing. It's fairly innocuous when seeing fake AI-generated images online posing as real images, but dubious journals and medical articles pose a real risk for human health, and what advice the general public is following. Your comments, Dr. Chris Smith.
Whoever sent that in, I 100% agree with you, and it concerns me greatly. Now, where I think there's a major risk from AI is in the generation of content, which then ends up online, which then ends up in the corpus of published knowledge, and is then used to support other claims or hypotheses or to reinforce other people's argumentation. And why it's a worry is that these systems confabulate information. I saw this for myself at the hospital the other day. There was a group of us that were interested in what are called eponymous syndromes. These are medical disorders that are named after some famous person who discovered them 100 years ago. There are loads of them. There's Pott's disease, there's Wilms tumour, there's loads and loads of these conditions named after the person who discovered them. So we put in that we wanted to know about a certain type of these eponymous syndromes, and we wanted to know what the name was, who discovered it, and a bit about the background. And ChatGPT generated a list for us, and we went down that list saying, yep, seen that one, recognised that one, heard of that one. Oh, this is new. Fourth on the list was this syndrome that 4 of us who were sitting there at the hospital had never heard of. And so we all thought that's fishy and went and looked it up, and it didn't exist. The engine had completely confabulated it. Now, if, for instance, I was a slightly less diligent doctor and I was giving a talk, and I just cut and pasted that list that ChatGPT had generated for me onto a PowerPoint slide and said, here's some examples of eponymous medical syndromes, then someone in the audience would have written that down. Some people would have photographed those slides. They would have all ended up on the internet in one way or another, because we all publish all our stuff to the internet these days, don't we? Then along come you, Clarence, and you're searching up eponymous syndromes in medicine, and you've heard of Chris Smith, and you thought, well, he's probably got a thing or two to say, so let's see what he thinks on this. Oh, look, Chris has said there's this, and this. Now, instead of ChatGPT inventing it, Chris Smith has said it, and that gives it some additional authority. And because Chris Smith and Clarence then said it, then the next person who comes along can find several other people who appear to be citing this, and before you know it, it's all built on a house of cards, and we are polluting our knowledge space. This is the E equivalent of the plastic of 100 years hence. We have this amazing technology, but it is polluting our knowledge space if we are not careful. And that will have long-term consequences for the integrity of the information that we all rely on for how we go about our business. And there's a whole industry, and this person mentions medical journals and things, there's a huge industry around this where to make money, journals help people to get published. And so what these journals do is that they will accept really low-grade publications from people who pay to have them published. Then they can put them on their CV and said, I did this piece of research, this is what I found, and this is what I published, whatever, and that helps them to get a job. Lots of those papers are being churned out by people for whom English is maybe not even their third language. They've not actually done any work. They just want to write this review about something, and they ask a large language model like ChatGPT to just write it for them. And then the journals, no proper editorial process, they just publish it and charge the person $2,000. And as a result of that, again, you've polluted the knowledge space in a very bad way. So I am very concerned about this. And at the moment, it's flying under the radar. It's too young, this technology, for people to have realised this is a problem. It's a bit like vaping was 10 years ago, where there seemed to be some major advantages to vaping. It helped people get off cigarettes. But the undercurrent was loads of young people who would never normally go near tobacco products are now getting hooked on this. And it's going to become a health problem, the scale of which we have no idea yet. This is the same in the same ball game, I would say.
Okay, let's go on to Denver's question. During my wife's pregnancies, why did I have all the cravings? Watermelon and peanut butter, sushi and knickknacks? Interesting.
he's just greedy. No, I think it's perfectly possible that you think, well, it's a stressful time, isn't it, when you're having your first or even your second baby, and you're thinking, well, I deserve a few treats, and I just could go a bit more melon. And before you know it, because one person's letting themselves indulge a little bit or taking life a little bit easier to reward themselves for doing the huge job of growing a baby, the other partner joins in. So I think this is what's called a phenocopy, where one person ends up with the same sort of phenotype and perhaps putting on a bit of weight or whatever as the person who's already got that trait, because they are living the same lifestyle and behaving the same way. You might do a bit less active, you might stress a bit more because it's demanding doing all this, and it leads towards a bit of comfort eating and a bit less good quality sleep, which also tends to promote hunger. So I think there's a range of reasons why, but I think they're mainly psychological.
Denver, there we go. That's your question answered. Let's take a listen to a voice note.
Goeiemôre, Clarence and Dr. Smith, man. Dr. Smith, Flores here from Worcester. Dr. Smith, farting. Why does these soft farts smell so much than these hard, bouldering farts? Especially if you work in an office setup, and some people, I think they're making a joke out of it by coming up with these soft parts, man, and this whole area just stinks. What is the chemical reaction there between a soft part and a hard part? Have a good job, Baba.
Rather graphic, thank you.
I wouldn't want to work in Floris's office, would you? Where does he work, for heaven's sake? At the sewage works or something?
There's some competition going
Is this
there,
like
clearly.
chemical warfare going on in that office? Well, first of all, I mean, what is a fart? The intestine produces prodigious amounts of gas, multiple litres of gas per day because of the action of microorganisms. There are trillions of them in our guts. There are more microbes cells in our guts than there are human cells in the whole of the rest of the body, in the average human. And those bacteria all have metabolic knives and forks, enzymes and degradative chemical machinery to break down food. And what we eat, they eat. And some things that we can't eat, they can. Because there are some things that we just can't digest. Hard cellulose, the woody stuff in plants, that just goes straight through into the large intestine, and it's soluble fibre. It helps to keep us regular. But those microbes, some of them, can break that stuff down. So when they start chewing into it, one of the byproducts of them breaking it apart are gas molecules. A lot of CO2, some hydrogen, and there's also some methane. So yes, some people have a more methanogenic bowel than others, but yes, you can set light to farts. But please don't do this. You can set fire to your clothing or your house, and that can be destructive and extremely dangerous. But there are also some chemicals in the foods we eat that are sulfur rich. Things like onion, things like garlic, things like cabbage. They have strong flavours because they have sulfur-containing chemicals in them. And those sulfur-containing chemicals, again, are food for microbes. And when they metabolise them, they produce a whole range of small molecules that contain sulfur. Hydrogen sulfide is one, stinks like rotten eggs. Another is methyl mercaptan. It's the same stuff we put in natural gas or gas that comes out of cylinders to make it smell so we can tell when there's a gas leak. This is a similar family of molecules, sulfur-rich. Now, they are produced generally in small amounts. So the kinds of foodstuffs that produce these low volume but high potency, what we might call silent but deadly farts, they're very, very dominated by these sulfur compounds. Don't need very much of this to absolutely stink. And when you smell some of these sulfur-containing compounds, all you need to do is literally take the top off the bottle and it reeks. It's horrible. And so that's the reason why you don't need very much, and you can squeeze out a sly one and it really stinks, but no one will know who did it because they're not bulky. You don't need very much. The gas is very, very potent. Things that produce large volumes of gas, that are things like big, bulky, loud, rip-roaring, kind of raised leg, lavish farts, that sort of thing, those tend to be less odoriferous because they tend to be made from chemicals which are more like the celluloses I mentioned, which just generate large volumes of CO2, but they're not producing large amounts of sulfur compounds. So as a result, they don't tend to be whiffy, they just tend to be noisy. So it's noise pollution rather than air pollution.
Now, we've been talking about, is it 2024? Why 24? And I think this question is related. Jeff asks, how does science differentiate between a dangerous meteor heading straight for the Earth and an asteroid doing the same, and which could be more dangerous?
Well, Jeff, the answer is that we do actually have an NEO program, Near Earth Object Tracking Program. This is because there is a risk that there are objects out there which may end up on a collision course with the Earth. The next one we've got our eye on is actually due in 2032, and this might end up with brushing past our planet sufficiently close that it might end up coming in and hitting the planet. Now, what makes the impact is that these things are moving at thousands and thousands of kilometers an hour. So they're going very fast and they've got a lot of momentum. So the amount of energy they have is partly down to their speed, but it's also down to their mass. So the bigger the object is and the faster it's going, the harder it will hit the Earth. And when you have something which is tens of kilometres across, like a city slamming into the Earth's surface, that's the kind of thing that's of the scale that wiped out the dinosaurs. Because when they come in, if they smash into the Earth's surface and unleash all that energy, they will throw up enormous waves if they hit the ocean. They will throw up dust and dirt and other things into the atmosphere. And it's a bit like a nuclear winter, because this will form a shroud around the planet and block out sunshine. This will have the effect of cutting down plant production because plants need sunshine to grow. And if you cut down plant production, plants feed pretty much everything on the planet because they're nature's solar panels. They capture the sun's energy, turn it into chemical energy, and that feeds us. So if you block them out, you will then starve the planet. And that's what happened to the dinosaurs. That's at one end of the scale. Other objects are much, much smaller. There's obviously a problem that as they get smaller, they're harder to see, but that's where this program comes in. We're trying to find all the objects. We know because they follow orbits, we can make reasonable predictions, and as we track them more and improve the precision of our measurements as they get closer to us and we have more data, we can refine their paths. We can work out which ones and when are more or less likely to come close enough to the Earth to be within the bounds of the uncertainties that we have about their trajectory to have a reasonable chance of hitting us. The best prospects at the moment is a couple of % chance that something's going to hit us. But that means we're forewarned. We can then gauge their size because their size tells you can work out how big they are based on how big they are on the telescope and so on. And then you can decide, well, what are we going to do about it? And we've already done the experiment. If you remember the experiment that was done recently where they slammed a large chunk of something into a tiny moon orbiting an asteroid to see what it would do, we now have some measurements, physical measurements of how we might divert a potential impactor like that.
Thank you, Dr. Chris Smith, the naked scientist, lecturer at the University of Cambridge. That is all that we have time for this morning. It is 2 minutes to 10 o'clock. News coming your way at the top of the hour.
This is Views and News with Clarence Ford.
Only on Cape Talk.